Most unit tests you and your team write are useless. Here's why. The actual goal of testing is not to prove that your code works right now. The goal is to ensure that your code does not break when you change it. In other words, your test should give you confidence that you can change things without breaking the behavior of the software at large. This is important since every code is a liability. And this is especially true for test code, since it is a client of the code it tests, and this creates a direct dependency to that code. This is important to understand because coupling is something we want to avoid. So you should write as few tests as possible and as many as necessary. How can you improve this situation? First and foremost, you need to learn the basics what define a good unit test. The simple ones that everybody knows are like fast feedback, the test should be automated, they should be independent of other tests, and they should be reliable. But this does not cover all the bases in my experience and is also way too vague. Actually, there's a better way. The following equation shows the quality of any given unit test. It is built on 4 pillars. Each pillar is one factor in this equation, and each has a value between 0 and 1. So if one of these factors amounts to 0 or close to 0, the test is useless. Of course, this is not an exact science, but you must estimate the values for each pillar and for each test. You will probably also notice that this equation has factors that are mutually exclusive. So you'll have to make trade-offs and can never achieve a perfect test score. Like think of the protection against regressions, it stands against all the others. The more code you test, the slower the test becomes and the harder the arrange phase of your test becomes. Also, you could argue the refactoring safety is the most important one because remember, you want to be confident that your changes didn't break any code. So if you have no refactoring safety or close to 0 refactoring safety, the test doesn't prove it and can never prove this. So if this has a low estimated value, go ahead and sacrifice the others until this goes up and leaves the overall test score above 0. The second thing we need to understand is the term unit and how it is misused. Open up any unit testing guide and they most likely will tell you a unit is represented by a class. But think of this with the equation in mind. A class is just an implementation detail. You could as easily use just functions to achieve the same, but what about the tests coupled to this class then? Because your test code is a client of your production code. That means the refactoring safety goes to 0 quickly and makes such tests useless in most cases. That's why it is better to think of the unit as desired behavior. This behavior can be achieved by any means: a stored procedure, a graph of objects, lots of chain functions, or just a single class. It doesn't matter to us, and the test must not reflect it to achieve a good quality score. Another way to think about this is the white box versus black box testing analogy. White box testing assumes we know all about the insides of the system under test, which will most likely be a class. Black box testing, on the other hand, just sets up the inputs and then asserts if the outputs are as expected. The black box tests regularly score way better with the test equation. This way of thinking also helps you to get a better designed software overall. It will force you to think of your public APIs and design them to be deeper. And in the end, your code will encapsulate the desired behavior all behind one simple interface. And this will lead to code that can be changed with confidence of not breaking anything. Another problem I often encounter in the wild is the use of mocks. Mocks simulate dependencies of the class under test or the system under test. They are certainly helpful to get control of mutable shared dependencies. Think databases, file systems, third-party systems with write access, and so on. In the wild, most people subscribe to the so-called London School of Testing. Not only regards it the unit as a class, but it also tells you to mock everything that is not the class under test. This has multiple severe problems. The unit definition we already talked about, but also mocking everything is a huge red flag. Firstly, it leads to more indirection than necessary, which makes the code more complicated to understand for other developers. And as we all know, everything can be fixed with more indirection, except for the problem of too much indirection. And the second problem is that dependencies, even if they are mocked, are just an implementation detail. And as we learned before, we want to avoid to test implementation details. When we look at our equation, pretty much every test written in this way gets a score of 0. So it's useless and maybe even harmful when you consider that it's a liability and couples your code to the production code. Mocks are not totally useless though. Instead of mocking every single dependency, you should just mock the mutable shared dependencies and maybe the out-of-process dependencies or third-party dependencies that you cannot control. And at last, I want to show you the part of code you ought to test, or the parts of the code. For this, we can think of most code bases in 4 categories. These are distinguished by two axes. The vertical shows the complexity of the code in relation to the domain significance. The horizontal axis shows the number of collaborators. The first category has minimal amount of collaborators, probably 0, and little to no domain significance. These are, for example, functions, constructors, getters and setters, and similar things. The second category has lots of collaborators, and we can call this code controllers or orchestrators. The next category has lots of collaborators and is highly complex. This is the overcomplicated code that is hard to understand and hard to change. The last category is the most important one, the domain logic. It has minimal collaborators and is highly complex. In the best cases, it actually has no collaborators that are out of process, like databases and so on. This is also the code that is the only one you must test. It's the reason the software exists after all. Trivial code must not be tested at all, since it is exactly that, trivial. The overcomplicated code is the one you should refactor to make it more testable. And controllers or orchestrators could be involved in integration tests or similar, but should never be tested by themselves. Since the only thing they should do is delegate anyways, it leads to a white box test because you have to know the implementation and probably mock everything. And we talked about that before. So this is how you improve your test suite then. Check all tests on how they score on the equation. Make sure to only use mocks for out of process and mutable shared dependencies, and test all of the domain logic and maybe some of the overcomplicated code if you cannot refactor it beforehand.